General Organic Chemistry, GOC. You take the running notes. Don't expect to expect notes each and everything. You just take notes. Wherever important points will be there, I'll give the like note. So General Organic Chemistry. So to understand organic chemistry, this is like backbone. Okay, whatever we study concept in general organic chemistry, so it helped to understand organic chemistry. Okay, so that's what it's very important to understand organic chemistry, right? So what is general organic chemistry? What we study in general organic chemistry, we study about reaction, how the reactant converts into product. When the organic reactant converts into product, what are the reactions takes place? Okay, so when you see the organic reaction, generally organic reaction contains substrate plus there is a reagent. Substrate and reagent both are actually they are reactant. Take the running notes. Okay, substrate and reagent both are reactants. So therefore substrate and reagent combine to form, initially they form intermediate, right? They form the intermediate, or in some reaction there may be a transition state TS, which is called a transition state TS. Okay, intermediate is unstable, even transition state TS also unstable, it gives finally product. Now this is the sequence of organic reaction, right? So therefore now say substrate plus reagent, they combine, they form intermediate or TS, which gives finally product. Now we need to understand what is the reagent and what is the substrate. So here substrate is a reactant, right? The reactant which is attacked by the reagent. Remember, reagent always attack the substrate. This reagent always attack the substrate. So therefore, what is the substrate? Substrate is a, of course, reactant. The reactant which is attacked by the reagent is called substrate. Then what is the reagent? Reagent also reactant, but the reactant which attacks the substrate, right? It is the reactant which attacks the substrate is called what? Reagent. Okay, so therefore in reaction mechanism, reagent and substrate both combined, they form intermediate and finally product. Okay, next is the first concept in GOC is mechanism, reaction mechanism. So what is the reaction mechanism? Tell me. So already we have studied reaction mechanism where in chemical kinetics. So what is the reaction mechanism? The detailed step-by-step explanation of a chemical reaction. The detailed step-by-step explanation of a chemical reaction is called reaction mechanism. Okay, to understand reaction mechanism, organic reaction mechanism, there are 4 concepts are established, right? To understand reaction mechanism, there are 4 concepts are established. 1, cleavage of covalent bond. 2, attacking reagent. 3, reaction intermediates. 4, electronic effects. So therefore, to understand reaction mechanism, so we need to understand these 4 concepts. 1, what is the cleavage of covalent bond? 2, attacking reagent and types of attacking reagent. And 3, reaction intermediates, what are reaction and types, and finally electronic effects. Let's see, first one is cleavage of covalent bond. cleavage of covalent bond. So we know that covalent bond is a bond which is formed by mutual, it is a mutual contribution and sharing. So a bond which is formed by mutual contribution and sharing of pair of electron between the two atoms is called what? Covalent bond. It means a covalent bond is always formed by sharing of pair of electron. For example, a covalent bond present between AA. So this means it indicates that there is a one pair of electron. A pair of electrons are shared between the two atoms. So that is the meaning of covalent bond. Now we will study what is the cleavage of covalent bond. So cleavage nothing but breaking, it is nothing but fission. So cleavage nothing but breaking of covalent bond. Cleavage of covalent bond usually takes place in two types. One, homolytic cleavage, second one is heterolytic cleavage. Homolytic cleavage is also called symmetrical cleavage or homolytic fission. Cleavage is called fission. Then heterolytic cleavage is also called heterolytic fission or unsymmetrical cleavage. Therefore, types of cleavage of covalent bond. One, homolytic cleavage, which is also called homolytic fission. And which is also called symmetrical cleavage. Okay, then what is a symmetrical cleavage or homolytic cleavage? See, let us take example atom AA. In between atom AA there is a one covalent bond. This covalent bond is made up of pair of electron, two electrons, sharing of two electron. Now tell me, when this is called homolytic cleavage? It is called homolytic cleavage when the cleavage of covalent bond takes place in such a way that each atom, bonded atom, gets one electron. That means both the bonded electron get one electron each. It means where the bond has to cleave? Bond has to cleave in between two electrons like this. So that this atom gets one electron and atom B also gets one electron. So these are called what? Free radicals. So therefore, what is a homolytic cleavage? The cleavage of covalent bond takes place in such a way that then both the bonded atoms gets one electron each. So this atom gets one electron each, this atom also gets one electron each. As a result, so homolytic cleavage always gives free radical. So therefore, definition is the cleavage of covalent bond takes place. The cleavage of covalent bond takes place in such a way that both the bonded atom gets one electron each. So both the bonded atom gets one electron each. Okay, then so as a result, now tell me, homolytic cleavage always gives what products? So homolytic cleavage always gives free radicals. Therefore, it gives a free radical. What are free radical? We study later. Next, then homolytic cleavage also denoted by, it is called half-headed arrow or fish hook arrow, which is called half-headed arrow or fish hook arrow. Therefore, it is denoted by half-headed curved arrow. Half-headed curved arrow, it is also called fish hook arrow, like this. Okay, next, This homolytic cleavage is favored by helper. It is favored by the helper. What is the meaning of helper? Tell me. Homolytic cleavage takes place, or it is favored in presence of helper. Helper andre H is a heat, E is a electricity, L is a light, and P is a peroxide, and R is a radicals. Therefore, it is favored by heat, electricity, light, peroxide, and finally radicals. So this is about homolytic cleavage. Next is heterolytic cleavage. Heterolytic cleavage is also called heterolytic fission or unsymmetrical cleavage. Unsymmetrical cleavage. Okay, now tell me, in case of, you see, homolytic cleavage. So what is a homolytic cleavage? The cleavage of covalent bond takes place in such a way that both the bonded atoms should get one electron each. So then when it is possible, when both the bonded atoms get electron each, both the bonded atoms get one electron each if there is a cleavage takes place in between, exactly in between the bond, right, in between two electrons, so that one electron gets A and other electron gets B, so that we will get free radical. But in case of unsymmetrical cleavage, what? For example, let us take here AB. Now this AB has of course two electron, that is a covalent bond. A covalent bond is always formed by two electron, right? Now tell me, the cleavage of covalent bond takes place in such a way that both the bonded atoms taken by one of the joining atom which is having more electronegativity. Suppose if the B atom has more electronegativity, this both the bonded electron taken by whom? B. That is B. It means two electrons will be here, then the cleavage of bond will be like this. So that as a result, A gets A plus, B gets B minus. That means you will get cation and anions are formed. Therefore, what is the definition of heterolytic cleavage? The cleavage of covalent bond takes place in such a way that both the bonded electrons taken by one of the joining atom, right, in such a way that both the bonded electron taken by one of the joining atom having more electronegativity. Okay, so therefore now here both the bonded electron, it means two electron taken by B, it means B is supposed to have more electronegativity. So B has more electronegativity, therefore this bonded electron taken by only B. So therefore, now tell me, this heterolytic cleavage denoted by how? It is a complete arrow, right? Full headed complete arrow. And what are the product formed here? Cation and anion. If it is case in organic compound, carbocation and carbanion. So therefore it gives cation and anion. So therefore unsymmetrical cleavage always gives cation anion. Next point, it is denoted by complete arrow like this. Next, finally, it is favored by what? Homolytic cleavage favored by helper, but it is favored by polar solvent like water or even alcohol, acetic acid. In presence of polar solvent, heterolytic cleavage is favored. Therefore, it is favored by polar solvent. I'll write here. It is favored by polar solvents like water, comma, alcohol, comma, carboxylic acids are the polar solvents. Right? So therefore, it is about first concept, cleavage of covalent bond. See, what are the possible questions can be expected in NEET exam? It was previous CET question also. Which of the following cleavage gives free radical? Homolytic. Which of the following cleavage gives carbocation carbanion? Heterolytic cleavage. Right. Homolytic cleavage favored in. So any one of this, helper, homolytic cleavage, helper. It is heat, light, electricity, peroxide, radicals. And heterolytic cleavage is generally favored in polar solvent. For example, we study SN1 reaction. SN1 reaction takes place in polar solvent because there is a heterolytic cleavage takes place. Right? And free radical substitution, we study alkane. Alkane undergo free radical substitution, that is favored by helper because it is a free radical substitution reaction. That's what, so we will apply in different concepts. It is about cleavage of covalent bond. So ಇಲ್ಲಿ ಇಷ್ಟೇ ಬರೋದು important, which cleavage gives which products. Okay, next. Which one? Homolytic cleavage polar solvent. Non-polar. Okay, what about nature of the solvent you are asking here? Homolytic cleavage. See, generally polar solvents are two types: polar protic, polar aprotic. Okay, so polar protic, polar aprotic, both are favored in heterolytic. Okay, in case of heterolytic cleavage, it depends on the reactant. Suppose reactant is a polar. If the reactant is a polar, we should take polar solvent. Polar aprotic solvent should be taken. That's what the nature of the solvent we don't study here. It varies. The nature of the solvent varies in where homolytic cleavage change ಆಗುತ್ತಾ ಇರುತ್ತೆ. You cannot tell that only non-polar solvent, but majority cases non-polar solvent can be taken. For example, alkane. For alkane we take N-hexane. N-hexane is a solvent. That is a non-polar solvent. But it is not always non-polar. That's what effect is different. Okay, fine. So this is the first concept is what? Cleavage of covalent bond. Second concept is attacking reagent. So what is attacking reagent and types of attacking reagent? So attacking reagent is in a organic reaction there is a substrate plus reagent. So here reagent always attack the substrate, but substrate do not. Substrate do not attack reagent. So reagent nothing but that's what it is called, attacking reagent. Reagent always attack the substrate, therefore reagents are called nothing but attacking reagent. Okay, then what is a reagent? Reagent is a reactant, the reactant which attack the right, therefore It is the reactant which attack the substrate. The reagent which reactant which attack the substrate is called what? Nothing but reagent or attacking reagent. So here we studied two types of attacking reagent. One, electrophiles, nucleophiles. There are two types of attacking reagent, electrophiles and nucleophiles. So here also say concept is very big, but no, questions comes like this: which of the following electrophile which is a nucleophile, which is not electrophile, which is not a nucleophile. Iste baro questions. Therefore we need to focus on how to identify. Ist nempedu saku ella concept bekagila. That's what we go for directly, that only. Tell me, what is a electrophile? So electro means electron, phile is loving, right? No, okay, we'll see first this. So what is a electro? Here electro is a electron, phile, the meaning of phile is loving. So what are electrophiles? Electron loving species, right? Asani, electron loving species. It means electrophiles, they seek of electron, they love electron. It means they are electron deficient or electron rich? They must be electron deficient. Since they are electron deficient, they are electron seeking reagent, electron loving species. That means they wanted electrons. So therefore, how do you define electrophile? In simple term, electrophile is nothing but electron deficient species, right? Electron deficient species are called electrophiles. Okay, so therefore the definition of electrophile is electron deficient species. So electron deficient species are called electrophiles. Can we say electrophiles are electron pair acceptors? Yes, because they accept electron, no. So therefore electrophiles are electron pair acceptor. But we also know that electron pair acceptors are what? Lewis acids. Very good, they are Lewis acid. Therefore these are generally Lewis acids because they are electron pair acceptor, and even they are electron loving species, right? Electron loving species. Okay, so these are the other names of the electrophiles. But as I told you, how to identify electrophile, that is, the following species can act as a electrophile. Which following species? Write that only. Following species can act as electrophile, and moreover electrophile denoted by E plus. Electrophile they denoted by E plus. Right. So which following species can act as electrophile? 1. Can I take all positively charged species? Why? If any species having positive charge, they are deficient of electron. No? They are deficient of electron. That means they can take electron. Right? They are electron pair acceptors. So therefore, all positively charged species. So all positively charged species are electrophile. Then example, many more example you can write, like H plus. It is electrophile. We use very commonly in organic chemistry. Next, R plus. What are R plus? Methyl, ethyl, propyl, butyl, pentyl, many more. Alkyl carbocation can be used. Next, X plus. Which is X plus? Except fluorine. Cl plus, Br plus, I plus. Why not F plus? So F plus has highest electronegativity. It has tendency to get a negative charge, not positive charge. It never lose electron. Okay. So therefore, it is a X plus. Even you can take NO2 plus, NO plus. Okay, many more. So all these are example for electrophiles, but there are exception. What is the exception for not electrophile? Exception is, say, all positively charged species are electrophile except first and second group metal cations. First and second group metal cations, they are not electrophile. They cannot take electron because, for example, sodium lose one electron, becomes sodium plus. Sodium plus has stable electronic configuration, and moreover, sodium, alkali metal, alkaline earth metal have tendency to lose electron. They don't have tendency to take electrons, right? Therefore, never. So therefore, all first group and second group metal cations are not electrophile. And next, aluminium plus 3, ammonium plus, also not electrophiles. So remember, exception is all alkali metal cations are first group, second group. First and second group metal cations and aluminium plus 3, ammonium plus are not electrophile. You just remember these exception. Except these, whatever the example is given, all are electrophiles only. Okay. So it is about electrophile, that is all positively charged species. Is it only positively charged species are electrophile? No, even there are neutral species. There are two cases. The neutral species in which central atom has less than 8 electron, that is called incomplete octet. The neutral species in which central atom has less than 8 electron, incomplete octet, can also act as a electrophile. Can you tell me particularly which group element can form incomplete octet? Very good, 13th group element. All the 13th group element, particularly boron compounds, boron halides, boron hydrides, aluminum hydrides, aluminum halides. Even second group beryllium also. Beryllium halide is also an example for incomplete octet, that is electrophile. Okay. And next is, so in case of free radical, tell me, free radical carbenes, free radical has 7 electron and carbene has 6 electron. So all these are example for what? Electrophiles. So therefore, second case is neutral species in which central atom has less than 8 electron. Neutral species in which central atom has less than 8 electron, which is called less than octet. 1. Beryllium chloride. Remember, beryllium halide, beryllium chloride, both are electrophiles. That is in second group. In 13th group, boron halide, BCl3, BF3, B2H6, boron hydrides, even aluminium, AlCl3, okay, then aluminum hydride, AlH3, okay. So therefore, all boron and aluminum compounds are electrophiles. Next, even free radical, for example, methyl radical, it has how many electron? Here 3 hydrogen, 6 electron, no. One hydrogen bond is, one covalent bond is 2 electron. Tell me, how many electron? 7 electron. So therefore, wherever free radical comes, particularly carbon free radical, all carbon free radicals having 7 valence electron. Therefore, it is also a electrophile. Next is carbene. Carbene is a neutral species, divalent. Neutral divalent species having 2 free electron. It has how many electrons? It has 2, 4, 6, just 6 electron. Therefore, carbene, dichlorocarbene. This dichlorocarbene used in Reamer-Tiemann reaction. So, Reamer-Tiemann reaction, it is the intermediate electrophile we used. Barkoli, Reamer-Tiemann. Reaction. So, these are all electrophiles. That's what here important is how to remember. That's important. Question is very simple. Which is electrophile? That's it. You have to identify. Next, third category is now neutral species in which central atom has less than 8 electron. It take electron. But there are some neutral species having vacant d orbitals. Right. The neutral species in which central atom has vacant d orbital can also be act as electrophile. Example, particularly d block elements, transition elements, compounds. Like example, FeCl3, titanium tetrachloride, ZnCl2, right? Even p block also. In p block, other than first element, like in a group, for example, nitrogen, phosphorus. Nitrogen do not have d orbital, but phosphorus has d orbital, right? Oxygen do not have d orbital, whereas sulfur has d orbital. So therefore, other than first element in a p block can also be have d orbitals, vacant d orbital. Okay. Therefore, third case is neutral species in which central atom has vacant d orbital. Right. Neutral species in which central atom has vacant d orbital can also be electrophile. For example, d block element, FeCl3, SnCl2, titanium tetrachloride, ZnCl2, even phosphorus, PCl5, SF, sulfur, SF6. So other than first element in p block also having d orbitals, they also act as a electrophiles. Okay, it is a third category. Next is fourth category. Fourth one is the neutral species in which central atom is bonded with more electronegative element. If the central atom bonded with more electronegative element can also act as a electrophile. So therefore, fourth case is neutral species in which central atom bonded with more electronegative element. If the central atom is bonded with more electronegative element can also be act as electrophile. For example, can you take all these example? Beryllium, because beryllium central atom which is surrounded by chlorine. The same condition will satisfy here. Can I take BCl3? Can I take CO2? Carbon, oxygen? Yes, BF3. Can I take SO2? SO3? Cl2O7, SF6, many more. If the central atom bonded with more electronegative element, which is also act as a electrophile. So these are the 4 conditions to identify the electrophiles. Okay. So questions are very simple. Which is electrophile, which is not electrophile. Other than this, we won't expect anything. That's what you have to memorize these conditions. Okay. Next is nucleophile. Nucleophile denoted by Nu minus. So it is a quite opposite to the electrophile. Electrophiles are electron deficient species or electron loving species. Electron loving species are electrophile. Nucleus loving species are nucleophile. Then what is the meaning of nucleus loving species? What is the charge of the nucleus? Positive. Therefore, so which species can seeking of nucleus? Obviously electron rich. So therefore, so what are the nucleophile? Electron rich species. Electron rich species are called nucleophile. 2. Nucleus loving species also. Nucleus loving species also called nucleophile. Or say electron rich species. Usually which species are electron rich? The species which are having one or more lone pair electrons. Okay. Therefore the species which are having one or more lone pair means electron pair donor, electron pair acceptor. Yes. Therefore electron pair donors. Electron pair donors are also called nucleophile. And finally nucleophiles are Lewis base. They are Lewis base and denoted by Nu minus. Okay. Then which following species can act as a nucleophile? The following species can act as a nucleophile. Tell me. The following species can act as a nucleophile. 1. Like quite opposite to the electrophile. In electrophile, what is the first condition? All positively charged species are electrophile. Here, obviously, all negatively charged species. Here, no exception. If there is a negative charge, it is nucleophile. But there is exception in where? Electrophile. So therefore, first condition, all negatively charged species. So example, you can take H minus, OH minus, like R minus. What are the R minus? Methyl, ethyl, propyl, carbanions, comma, X minus. What are X minus? Here you can take F minus. F plus cannot be taken, but F minus can be. F minus, Cl minus, Br minus, I minus, NO2 minus, Cn minus, many more. Wherever negative charge comes, that is a nucleophile, comma, acetate, alkoxide, many more. Okay, like R, NH, all are nucleophiles. Next, case 2. Case 2 is, see, there in electrophile, what we have studied second case? The neutral species in which central atom has less than 8 electron. Now here, neutral species in which central atom has lone pair of electron, one or more lone pair. So therefore, neutral species in which neutral species in which central atom has one or more lone pair electrons. And tell me where the or in which molecule there is a lone pair of electrons. Like for example water, it has two lone pair, right? And water compound like alcohol, two lone pair, comma ether, two lone pair. Like H2S, like similar to water, hydrogen sulfide, it is a thioalcohol, two lone pair, thioether. Okay, or next like ammonia. Tell me, ammonia derivatives, primary amine, secondary amine, tertiary amine also be taken. Okay, next even phosphine, like similar to ammonia, phosphine will be there, there is one lone pair, and substituted phosphines or also example for nucleophiles. Okay. Okay, then now tell me how to identify the nucleophile, means which is having lone pair. So here I have written dots, but in exam you cannot expect dots. Tell me, for example, question is like this: phosphine. Phosphine contain how many lone pair? One lone pair, because write the central atom. So central atom belongs to which group? 15th group. Therefore there is a 5 valence electron. All the 15th group elements having 5 valence electron, and there is a 3 hydrogen. We know that hydrogen is a monovalent. It form one hydrogen form one covalent bond, 1 2 3. Still there is how many lone pair? Lone pair is 1. So that's what LP equal to 1. Okay. So like that H2S, how many lone pair on sulfur? Sulfur belongs to 16th group, 6 valence electron. Then there are 2 hydrogen. So one hydrogen form one covalent bond with 1 electron. Still there are 2 lone pair. Lone pair equal to 2. Okay. So like that you can identify the lone pair. If molecule has at least one lone pair, which is a nucleophile. Okay. Next, third condition. Third condition is all organometallic compounds, important. All organometallic compounds can also act as a nucleophile. Tell me, so what are the organometallic compound? Like for example RMGX, there is a lithium compounds, copper compounds, many are there, right, where there is a bond between carbon and metal. For example Grignard reagent, CH3 MgCl, right, alkyl magnesium halide. Alkyl magnesium halide is a organometallic compound because there is a bond between metal always positive, carbon negative. Therefore you will get this what? Nucleophile. So carbon nucleophile, that is called carbanion. Even lithium, there is a bond between lithium and alkyl, copper and alkyl, Cu2, R2, Cu, many more. So wherever carbon and metal bond is present, which is called organometallic compound, organometallic compound is produces nucleophile easily. Okay, that is a third category. Fourth category, it was a previous question appeared in JEE. Fourth one is the organic compound which contain carbon-carbon multiple bonds. Right, which organic compounds contain carbon-carbon multiple bond? Alkene, alkyne, even benzene and its derivative also. Therefore wherever carbon-carbon multiple bond is present, all compounds are nucleophiles. So therefore fourth category is neutral molecules or neutral species having carbon carbon multiple bonds can also act as a nucleophile. For example, alkene, alkyne and benzene and its derivative. Tell me now, question is, why alkene, alkyne, benzene and derivative can act as a nucleophile? What is the reason? Why? How they have an electron rich? We know that carbon carbon single bond is a strong bond, right? It is strong covalent bond. Then other than single bond, if there is a one pi bond or two pi bond, then this pi bond is always formed by sideways overlapping, right? Sideways overlapping. Due to sideways overlapping, it is a weak bond. Due to weak bond, these pi electrons are delocalized electron. Okay, so these pi electrons are they are delocalized. They can jump. Okay, as per the condition, when situation changes, this pi bond may shift here. This pi bond may shift this side also, right? But not sigma bond. If the sigma bond is shifted, molecule changes. So that's what. So pi electron, if any molecule having pi bond, those pi electrons are electron rich. Actually, it is electron rich. That's what now benzene ring. Benzene ring is, it's a full of electron. How? There are 6 pi electron. This molecule has 6 pi electrons. That's what benzene ring is called, electron rich, right? Therefore, if there is a one or more pi bonds, so all those molecules are nucleophiles, right? So these are the important nucleophiles. Okay, then one important note. Important note is, which species are act as both electrophile and nucleophile? So remember, the organic compounds in which are having multiple bond with carbon, oxygen, multiple bond with nitrogen can act as a both electrophile, nucleophile. It means the neutral species in which are having multiple bonds between either carbon, oxygen or carbon, nitrogen. So it means carbon, oxygen multiple bond. Where it is possible? Very good. Carbonyl compounds, aldehyde, that is aldehyde and ketones, carboxylic acid, esters, amides, acid chloride, anhydride, etc. Next, where the carbon and nitrogen multiple bond is present? Cyanides, isocyanides. So therefore, important note, neutral species having multiple bonds between carbon, oxygen, carbon, nitrogen can act as both electrophile and nucleophile. Okay, examples. Let us take general formulas: aldehydes, ketones, carboxylic acids, esters, acid chlorides, amides, acid anhydrides, etc. and cyanides, isocyanides. No, amine not having multiple bond, no. Imine or CH double bond NH, okay, nothing but they are derivative of cyanides, imine, okay. So all these are act as both electrophile as well as nucleophile. Okay. Then now you may have doubt why they act as both electrophile nucleophile. So which condition makes them to act as both electro and nucleophile? See, you see the multiple bond. If there is a carbon-carbon multiple bond, carbon-oxygen multiple bond, we know that here this oxygen has more electronegativity, therefore pi electron shifted on oxygen. When pi electron shifted on oxygen, oxygen become negative, carbon become positive, and moreover this oxygen has lone pair, no? So due to presence of electron rich on oxygen, which is act as a nucleophile, due to positive charge here, electrophile. This is called electrophilic center, which is called nucleophilic center, right? That's what all these can act as both electro and nucleophiles. Next is ambidentate nucleophile. So what are ambidentate? It is just like ambident ligands, coordination compound. So ambident nucleophile. So ambident nucleophile is the nucleophile which contain nucleophilic center, two nucleophilic center. In two nucleophilic center, one is a neutral, another one is a negative charge, right? The nucleophile which contain two nucleophilic center, in which one is a neutral and another one is a negative charge, right, which is called ambident nucleophile, right? The nucleophile which contain two nucleophilic centers, in which one is negative and another one is neutral. Like for example, C triple bond N, where C negative, N is neutral. C triple bond N, and nitrite N O N double bond O. This is negative, it is neutral. Next is nucleophilicity. In 2019 question paper, one question asked in nucleophilicity. What is nucleophilicity? Order of nucleophilicity. Okay, tell me, what is nucleophilicity? What is the property of the nucleophile? Nucleophile always attacks the substrate, and of course both electrophile, nucleophile, no, electrophile, nucleophile both always attack the substrate. Then particularly nucleophile attack where? Nucleophile attack always electron deficient center, electron rich center, electron deficient center. Therefore, now what is nucleophilicity? The tendency of the nucleophile to attack the electrophilic, electron deficient center, right? The tendency of the nucleophile to attack electron deficient center is called nucleophilicity. So it is a tendency of nucleophile. The tendency of nucleophile to attack the electron deficient center. Electron deficient center called nucleophilicity. Then what are the factors affecting on nucleophilicity? Okay, so what are the factors affecting on nucleophilicity? There are three important factors. One, electron density. or are negative charge? Tell me. So we know that nucleophile has tendency to attack on electrophilic center, that is electron deficient center. Can you tell me nucleophilicity depends in what way it is depends on negative charge electron density? So you just imagine there are two nucleophiles. One nucleophile has less electron density. Another nucleophile has more electron density. Tell me which can attack on nucleophilic center, electrophilic center, which is having more electron density. It means, so nucleophile property is it is a attacking and donating, right? It attack electron deficient center and donate electrons. It attacking is nothing but after attacking it form the bond, it donate electrons. So therefore when the nucleophile can donate electron, if it has more electron density, therefore what is the relation between nucleophilicity and electron density? It is directly proportional. So we wanted to remember only this: nucleophilicity directly proportional to electron density or negative charge. Okay, that means more negative charge, more nucleophilicity. For example, let us take water and OH. Can you tell me, among water and OH, both are same kind, which has more nucleophilicity? Obviously OH minus. That's it. Like H2S, HS, and ammonia, NH2 minus, alcohol, RO minus, like amine or NH minus. So therefore when there is a negative charge, obviously its nucleophilicity increases, right? Second factor is electronegativity. Based on this, in JEE question was given in JEE. Electronegativity. Tell me, so what is the relation between electronegativity and that is nucleophilicity? So nucleophilicity, it is a measure of nucleophile to attack and donate. Usually the function of nucleophile is nucleophile attack the substrate, subsequently it donate the electron pairs. Okay, not only attack, it donate, attack and donate. Then tell me, in order to donate electron, it should have less electronegativity, because if an element has more electronegativity, it cannot lose electron, it cannot donate electron. That's what. For example, you can see in 17th group element, fluorine, fluoride, chloride, bromide, iodide. Tell me, what is the order of nucleophilicity? So iodide is more than bromide, then chloride, then fluoride. That means nucleophilicity inversely proportional to electronegativity, right? Then now for example, you can take it is in a group, right? In a period, let us take carbon, nitrogen, oxygen, fluorine. Okay, so what happened? Carbon to fluorine, electronegativity increases, then nucleophilicity, yes. Nucleophilicity, how come? I think ಬರುತ್ತೆ. Nucleophilicity directly ಬರಲ್ಲ. ಏನು ಬರಲ್ಲ ನೋಡಿ. Now see, if you take size, fluoride, chloride, bromide, whose size larger? Iodide, no. Size of I minus is larger compared to F minus. If any atom has large in size, then what happens? Its nucleus force of attraction on valence decreases. Therefore iodide has large in size, its nucleus unable to hold this electron very strongly, so that this electron can be donated easily, right? So that means if you, third factor is atomic size, or what is the size of the nucleophile? Size of nucleophile. Tell me, what is the relation? Nucleophilicity is directly proportional to size, right? As the size increases, nucleophilicity increases. The same example, F minus Cl minus Br minus I minus can be taken. Okay. So this question asked in JEE. Same. Which of the following has more nucleophilicity? Answer was I minus. It is about attacking reagent. As I told you, here expecting questions are which is electrophile, which is nucleophile. It bitre bere question illali. Otherwise, which of the following has more nucleophilicity? Which of the following has less nucleophilicity? Strong nucleophile, weak nucleophile. This kind of question can be expected. Otherwise, which is nucleophile, which is electrophile, which is both this. That's what better you should remember. What conditions? So this is about a second concept. Third concept is reaction intermediate. Right on. Reaction intermediate. Okay. Reaction intermediate. In organic reaction, we have studied there is a substrate which is reacts with attacking reagent, which gives rise to what? Usually intermediate. In some reaction, there will be a TS, and this intermediate finally gives product. Okay. Now see, we have studied reagent. Okay, we have studied about in a cleavage of bond, and next we will study about intermediate. Tell me, what are intermediate? Intermediate are very shortly lived, right? They're actually their lifetime is very short. The very shortly lived highly reactive species, they are highly reactive. Therefore, a very short lived and highly reactive species are what? Reaction intermediate. Okay. So therefore, reaction intermediates are very short lived. It is around 10 power minus 6 seconds, then you can imagine, and highly reactive. Very shortly lived and highly reactive species are called reaction intermediates. Okay. So usually reaction, to understand reaction, reaction intermediate, you need to understand this graph. Let us take this is a potential energy on y axis, reaction coordinate on x axis. Okay. In chemical context, we have drawn the graph, right? Same, it is called a P graph. In the P graph, usually reactant having lesser more energy, okay, more energy, that is exothermic, fine. Reactant having more energy, ER, energy of the reactant, right? When reactant converts into, okay, product, what is the intermediate, right? So therefore, there will be a intermediate here, right? This is intermediate, which is gives then finally product, EP. Now this point is a intermediate. Now tell me, what about this? This is actually transition state, TS1, it is a TS2. It means, see, important point, remember, when the reactant converts into intermediate, the first TS is formed, the imaginary state. That means where we have written here substrate plus reagent, okay, it form intermediate, but actually before intermediate there is a TS comes, TS1, transition state 1, then converts into intermediate, it's somehow stable, then before converting to product, this intermediate again gives one more TS, then product. Now question is, what is energy now? Energy of intermediate, energy of TS. Whose energy is more? Energy of TS. Energy of TS is always more than energy of intermediate. Therefore, stability, which is most stable? Intermediate is most. Therefore, first point here, energy of TS is greater than energy of intermediate. Next point, stability. Intermediate is more stable than TS. And one more important point, if you take one intermediate, okay, in some reaction there will be a 2-3 intermediate. If you take one intermediate always surrounded by how many TS? 2 TS, right? One intermediate surrounded by 2 TS. Suppose if I take 2 intermediate, it must be surrounded by 4 TS, right? 3 barutta. Now if you take the diagram like this, this is TS1 intermediate, like it is a TS2, is another intermediate, TS3. Okay, now if you take this intermediate is surrounded by 2 TS. Now it means every intermediate surrounded by 2 TS. So next point, every intermediate surrounded by 2 transition states. Okay, take the P diagram. Next is types of intermediates. So what are the types of intermediates? One, carbocation, which is also called carbonium ion 2, carbanion, carbon anion 3, free radicals 4, carbons. So these are the 4 types of reaction intermediates. Okay, so first one is carbocation. Okay, we shall continue next class.